Okay, so I will be talking about generalized syllogistic reasoning, and I will be explaining why generalized syllogistic reasoning is worth to look at. And it's joint work with Daniel Brandt, Maximilian Mittenbühler, and myself. So first of all, syllogisms, I think that it's well known, but still to give you just a kind of a flavor of this. So we have two premises, like some B's are A's and all B's are C's, and then typically people are asked what, if anything, follows. And of course, it's not presented in this abstract way that we ask for letters, but we typically replace them by some kind of content. So very often it's been replaced by professions because they do not have so much background they require to solve these things. And we all know that content and background knowledge can have an effect on the way what people are answering. So the interesting thing about them is that they have been investigated for quite a long time. So more than a century of psychological research has been conducted, and philosophical research, of course, goes back more than 2,000 years. So we see that this is something where it's very important to get a feeling for that. And in fact, these syllogisms, they have been changed a little bit, and there were some kind of discussions on them. But what's very interesting is that in the last years, at least since 2012, in the seminal paper by Khemlani and Johnson-Laird, they have been established as a kind of a benchmark. Why? Because there do exist 64 problems, and these kind of problems have been used to test not only theories, but implemented models that can then make the kind of predictions if they do get it right or not. And of course, there's plenty of discussion about this one, but what we can say is the interesting thing is that the traditional research has focused on 4 quantifiers: all, some not, and no. And typically, the participants are presented with a set of possible conclusions to choose from in a multiple choice fashion, or if they are asked to kind of generate a possible conclusion, then of course they can give all kinds of answers, but what you perceive is that they follow what has been presented to them. However, despite of being a great approach and forming a benchmark and being able for lots of research, we see that in everyday language, we very often use different forms of quantifiers, like most, few, many, at least 3s, and so on. And they have been called in psychological research generalized quantifiers. Why? Because they do generalize over them. So we see that most, that might be something like which is more than a half or something like that. So they are used in everyday language. However, if we look on this traditional syllogistic research and just do always these 64 problems, then we see that it can have a potential implication on significance and validity. So because traditional quantifiers, they don't cover these all possible relevant quantifiers that we may use in everyday language. So it's a way that we restrict the participants in some sense to think within a kind of a box. I mean, we do not do this, of course, explicitly. It's something which may be inherently in the way we test this, because we always present these 4s. And what's interesting is, because these problems have this great impact on the way of research, we might miss a lot of processes. And in that sense, we can say, or being a little bit provocative, we can say it limits the significance and generalizability of the existing research. And so the basic idea is that we can extend the set of quantifiers so they do not only affect the premises, because there are more conclusion options to choose from. And then the selection of quantifiers could therefore have an impact on the reasoning behavior. And if this is the case, most findings could, in the worst case, just be an artifact of the set of quantifiers that have been presented, and therefore it's a potential threat to the kind of validity that we want to really know what kind of cognitive processes are underlying it, and not because there is this kind of restrictions. And so the research questions we were driven by are, first of all, are the results for traditional syllogisms stable, in a sense that what happens if additional quantifiers are available for the conclusions? Is there any kind of change in it or not? And second, are there potential differences in reasoning behavior between generalized and traditional quantifiers? So what did we do? I mean, you can find in the paper all the details. So what we focused on was we included just 2 quantifiers we think that are often used in everyday language and still are a nice extension of it. So we just used most, and because you see in the traditional ones that there's always forms of negation, of course, we have something like most not. And in the end, if you do this, then you figure out that you have 144 syllogisms. And of course, you know that you can bore participants to death if you force them to do all of them. But on the other hand, of course, because we are interested in the individuals as well, so we wanted to have a nice way to do this. And so we decided to run them in 3 sessions. And participants were asked to choose from 13 conclusion options, so the classical 9 one plus these most and most not. And then if you wonder why there are additional ones, because you can ask for the term order as well. And so we had all the 64 traditional syllogisms in it, so we can really compare how people deal. And we followed what has been conducted for very long now in this field. So we used professions as well. And we found 31 participants that did all these tasks. And so the first question is, can we figure out if there are additional effects of these quantifiers? And so we compared our data set with a data set containing responses to all 64, traditional in the classical first order sense. And so we compared based on the response patterns for the traditional tasks. So how does that look like? So this is a small heat map. I don't want to go too much into the detail, but what we see here, we have our Gen Quant data set, which is the above one. And here we have our traditional data set. And so what we see here is the kind of syllogisms. Of course, this is a kind of just a selection. And here we have all possible answers that can be given. And there is a certain form of mnemonics for the answers that can be given. But what you see is that those who are the generalized quantifiers, that there is not a difference between traditional data set and a GenQuant data set. So even if in the GenQuant data set they were presented with them, they did not choose them more in these cases than in the other way. So we can say that in some sense those are very similar. So we can say there is no substantial influence on the general pattern for traditional syllogisms, just looking on the kind of answers that have been given. And the RMSE between both data sets, in fact, normalized by the number of participants, is 0.04. So we see that there's really something that we can say this can be considered comparable. So in that sense, an additional response options in sense of that we can offer people most does not seem to invalidate or affect the results from traditional syllogistic reasoning research. And this is good news because generalized quantifiers can then be investigated independently. So think about this. If offering this additional answer would have had an impact, then we would need always, if we extend this, always to carry on not only the traditional ones, but everything else, because everything can influence each other. And in that sense, we can say, well, luckily, this is in some sense a way to see that there is independence of it. So additional quantifiers did not have that effect on the way of answering. But the question still remains. So can we say, or can we try to find and investigate the potential differences in reasoning behavior between generalized and traditional quantifiers? So how can we do this? How can we approach this? Well, the first question would be, are generalized syllogisms more difficult? Is it that people may do more errors in dealing with them? And for traditional syllogisms, the universal quantifiers are easier than particular quantifiers. We already know this in the traditional sense. But what's about the most and most not? Does that affect the difficulty? Does it have any kind of changes? And when, in fact, before we can analyze this for most and most not, of course, the question is, when is a syllogism solved correctly? And I was kind of vague so far about the meaning of most and most not, but now we need to be clear and precise what most and most not means, because obviously there can be different kind of semantics in it. But luckily, we can follow something which has been very often used in the normative theory in logics, like Westerdahl, for instance, that put most as it's equivalent to more than a half. So we see that this disjunction is greater than the number of elements that we have in A without those in B. And so if we follow this, of course, then we can see how we can evaluate this. And if we look at this graph, then we see we have here the correctness from 0 to 0.6 given. Here we have our quantifiers like just universal, universal plus existential, existential. So we see here what I have said before, that with existential it gets more difficult, so the correctness decreases. And if we look just on the generalized quantifiers, we see that in fact here we are they are harder. People do not perform not only for the universal plus generalized, so on. In that sense, we see that there is a difference to the existential that is rather low. So we see that with this most and thinking about possible exceptions where it may hold or may not hold. So in contrast to the universal, there is something in it. But the question is, what makes the task then harder in the case of generalized ones? And of course, there can be three reasons that we can have a quick look into. So the first one is we have more invalid syllogisms. Of course, I mean, if we have most and most not, then that will be add on the stock on invalid syllogisms. So there isn't something where the correct answer would be no valid conclusion. And in previous research, you can find out that, of course, invalid syllogisms, so this has been shown across every kind of study, and we have investigated that as well. So they are more difficult on average and as well for the single persons. So we see that this is harder. So how can we get a feeling for this potential source of difficulty? So we divided the task by average correctness into quartiles. So just looking into the quartiles of correctness. So does that change something? Is for those who perform well, is that a difference to those who did not? And in fact, we see that validity is very important for the easiest quartile, but within the lower quartiles, more invalids does not imply lower correctness. And so the proportion of these generalized quantifiers is strongly coupled with the correctness. And so validity does not explain the difference. The second one could be, well, we have presented this, of course, to logical naive reasoners. So maybe participants had different interpretations for that. How can we approach this? Well, some and most include the possibility of all following from the definitions from logics. Of course, we know Gricean and so on, but the question is, what is it in each individual? And we, of course, see that Gricean does not hold for each and every individual. And what you can see is that a majority of participants, in fact, stated that their interpretation of most excludes all. So Grice is okay. And the proportion of these responses given by the participants would be correct according to their interpretation does not account for the inference. If we have a quick look into this, so we see that the correctness between generalized and existential, so just those who are misinterpreted for them, they are very, very few. So we can say the last one that we can have a look is more difficult reasoning processes or more practice and first order logic tasks. That could be, of course, something. And so the difference seems to originate in the way the quantifiers are processed. And the question is, are the processes similar for generalized and traditional quantifiers? Well, if we have a look into this form of analysis, so we have here, each dot is an individual participant, and we have here our traditional quantifiers, here our generalized quantifiers, and we have here the relative performance of these. Between then, we see that the performance on tasks with traditional quantifiers predicts the performance on generalized quantifiers if you do the Spearman tests. So we see that, in fact, so there is not so much a difference in that. And so this hints at common related processes in that. And of course, this is a task, and we're currently working on that for cognitive modeling to identify and predict them, of course. So two limitations. So first of all, due to the exponential blow up in the number of tasks, only 2 additional quantifiers were included. Of course, we would have loved to investigate more of these ones. But the good thing is that at least we see that there's kind of an independence, so we can deal with that in future research. And identifying difference in the reasoning process was out of scope. So we have to focus on ruling out direct effects of the task structure. And so it still leaves a task for cognitive modeling. So to conclude, we conducted a large study, 144 syllogistic tasks. We have presented them to 31 participants. The major goal was to show, or at least we could support, that 64 traditional syllogisms, all the research, it's still valid. They are unaffected by additional quantifiers. So this is, I think, good news. Then second, the first analysis hint at a similar common process for solving generalized and traditional syllogisms. And we see that most and most not seem to be substantially more difficult. However, the increased difficulty is not an artifact of the validity of the task or the misinterpretations of the quantifiers. And of course, future research should look into extending the set of quantifiers and then especially on modeling these processes with a focus on generalizability of the quantifiers. And just to say, there are at least 2 cognitive theories, the PHM probabilistic heuristic model and the mental model theory, especially in M-Reasoner, who do predictions for that. So thank you very much for your attention, and I'm looking forward to your questions.